Greetings, welcome to this new video about Supermesh analysis. Solve the problem number 4. Let's consider this network consisting of 6 resistors labeled R1 through R6 as well as voltage source Vs and the current source Is. The question is to find the current I. Let's move on to the solution. First, let's begin by defining the number of meshes. In this network, it's evident that there are 4 meshes. This is mesh number 1, mesh number 2, mesh number 3, mesh number 4. Now let's proceed to assign the mesh currents in this network, and I will consider I the current in mesh 1, I2 is the current in mesh 2, I3 is the current in mesh 3, and I4 is the current in mesh 4. The mesh currents are chosen in the clockwise direction. After we finish the assignment of the mesh currents, we need to remove the branch contains the current source Is. Then we obtain our supermesh. By applying KVL in Supermesh, we can write R1 I2 minus I1 plus R2 I2 plus R5 I3 plus R4 I3 minus I4 is equal to 0. By replacing the resistors with their numerical values, we obtain 2I2 minus I1 plus 4I2 plus 8I3 plus 5I3 minus I4 is equal to 0. If we continue simplifying this equation, we obtain negative 2I1 plus 6I2 plus 13I3 minus 5I4 is equal to 0, and I will call this equation number 1. Let's go now to mesh 1. By applying KVL in mesh 1, we can write negative Vs plus R1 I1 minus I2 plus R3 I1 minus I4 is equal to 0. If we replace the resistors with their numerical values, we obtain negative 30 plus 2I1 minus I2 plus 3I1 minus I4 is equal to 0. If we continue simplifying this equation, we obtain 5I1 minus 2I2 minus 3I4 is equal to 30, and I will call this equation number 2. Let's move on now to mesh number 4. By applying KVL in mesh 4, we can write R3I4 minus I1 plus R4 I3 minus I4 minus I3 plus R6 I4 is equal to 0. By replacing the resistors with their numerical values, we obtain 3I4 minus I1 plus 5I4 minus I3 plus I4 is equal to 0. If we continue simplifying this equation, we obtain finally negative 3I1 minus 5I3 plus 9I4 is equal to 0, and I will call this equation number 3. We currently have 3 equations with 4 unknowns, which means we require one additional equation to solve this problem. In order to get this equation, let's focus on the current source Is. We can write Is is equal to I3 minus I2. That means I3 minus I2 is equal to 4, and I will call this equation number 4. After we finish applying the mesh analysis, we obtain 4 equations with 4 unknowns. We still only need to solve those equations in order to find the mesh currents I1, I2, I3, and I4. Those equations are expressed in matrix form as follows. Ri is equal to V, with R is given with this matrix. -2 is the coefficient of I1 in the first equation, the coefficient of I1 in the second equation, the coefficient of I1 in the third equation, and the coefficient of I1 in the fourth equation. Column 2 is the coefficients multiplying I2 in the first equation, second equation, third equation, and fourth equation. Column number 3 are the coefficients multiplying I3 in the first equation, second equation, third equation, and fourth equation. And the last column are the coefficients multiplying I4 in the first equation, second equation, third equation, and fourth equation. I present the vector of the unknown mesh currents I1, I2, I3, and I4, and the vector V is given by 0, 30, 0, and 4. Since this problem is quite difficult to solve, I created a MATLAB program that makes it easier, which given with this picture. If we run this program in MATLAB, we obtain the mesh currents I1, I2, I3, and I4. If we look here in our networks, we can see that the current I is equal to negative I1. That's why we can write I is equal to negative I1 is equal to negative 864.79 amps, is almost negative 865 amps. After completing the calculations, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. This is the current I we are looking for. If we go to Analysis, this Analysis, Calculate Nodal Voltages, we can see here that the current I is equal to negative 865 amps. Is almost the same value we have done or we have obtained by calculation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another example about Supermesh analysis. Take care and bye bye.